Hey folks, so if you have tried to build multi-agent systems, you probably have noticed the dozens of frameworks available out there. So things like AutoGen, CrewAI, Pydantic, Google Agent, Developer Kit, even the OpenAI Agents SDK. There's just so much to choose from, and a common question I get is how do I choose the best framework if at all that's possible? And so in this video, we'll cover two things. So first, I'll sort of highlight 10 things a multi-agent framework should do for you. And the value here is that as new multi-agent frameworks sort of come out, you can use this 10 dimensions, sort of critically evaluate and think through the utility that this framework provides. And then the second part, we'll work through sort of 6 specific frameworks and sort of compare how they sort of fare on each of these dimensions. And so I built a tool to make it easy for you to navigate this entire process. Let's dig in. Okay, so before we sort of start comparing any of the libraries across each dimension, I think a great thing to do is to sort of look at a standard implementation of an agent across each of these frameworks. And I've gone ahead and done that. So if you go to multiagentbook.com and you went to code samples and you went to Hello World Agent, you can see that we have implementations in AutoGen, in both the AutoGen low level and high level API. We have an implementation of a Hello World agent in the Google ADK, LangGraph, LLamaIndex, OpenAI Agents, and Pydantic AI. And a really useful thing to do would be to sort of look at the implementations across each of these. And so the core idea is that we define a simple tool and we define an agent and we sort of get that agent to address a task. What is the result of this computation? And it's the exact same thing, but implemented across multiple frameworks. And sort of going through this gives you a sense of like the API, the design decisions made by each of these frameworks. And so, for example, if we sort of took the AutoGen agent chat API and we compared that with LangGraph, one thing you can see off the bat is that on the left is 33 lines of code, 76 lines of code here. Just shows how much code you need to implement like just a basic agent. And another thing that you can do is sort of compare some of the quantitative metrics here. And so, for example, we can see that like the same concept, you need the least amount of code with AutoGen Agent Chat API and most with the AutoGen Core API, followed by LangGraph. And then in terms of runtime, and so I took all of these agent frameworks and I sort of executed the same thing. And right now it seems that the Google ADK, for some reason, seems to take the most time to run. These are just interesting insights you sort of glean by sort of interacting and exploring a tool like this for sort of comparing multi-agent frameworks. So I really encourage you to take a look here. A critical thing to note is that each of the frameworks that we will consider today is evolving really, really fast, and it can be challenging or even misleading to compare them in a static manner. What this means is that whatever core capabilities we sort of talk about today might change in about a month. And in order to sort of balance this out, I think the more interesting or useful thing would be to sort of critically consider a set of dimensions that any multi-agent framework should address. In my opinion, I think there are about 10 things a multi-agent framework should do. And for each of these dimensions, I have, I think, 1 or 2 questions that sort of help us sort of evaluate or interrogate how each of the frameworks sort of performs. So the first has to do with developer experience. So the first is, does the framework provide a high-level agent abstraction, mostly for ease of development, rapid prototyping? In addition to that, does it also provide low-level APIs for just precise orchestration of the flow of control across multiple agents? The second has to do with just the implementation philosophy of the library. Is it async first? And this sort of comes in very, very handy when you try to build multi-threaded or optimize modern Python applications. So for example, things with streaming and integration with interfaces like Fast API, Chainlit, or Streamlit. The third has to do with event-driven communication. Is the framework event-driven at its core? Does it also provide a runtime abstraction that enables things like independent local agents as well as distributed agents that live across multiple machines? Does the framework support things like checkpointing, state management? does the framework support things like declarative specification? So for example, can you sort of build or prototype your application, let's say Python, and then sort of serialize that to a declarative format like YAML or JSON, and then recover runtime instances of those agents or components from your serialized specification? Does the framework support things like debugging and evaluation tools? And so, for example, does it have a UI interface that lets you rapidly prototype, conduct a lot of experiments, run this agent, visualize the flow of messages across agents? Another thing, does it support a set of predefined multi-agent patterns? So this way, you think less about like implementing well-known patterns and can reuse some of the abstractions that the library provides. The eighth one is quite important: observability. Does the framework provide visibility into agent interactions? Does it integrate things like open telemetry for sort of logging agent activities? Does it support some clear deployment story? And then finally, is there a large, vibrant ecosystem sort of built around the project or around the framework? And now that we have all of these dimensions sort of outlined, I think the next thing we can do is to go ahead and compare each of these frameworks across each of these dimensions. And so the tool I'm showing here is sort of available for free. I'll put a link in the video right now. And essentially what we're going to do is that we're going to go through each of these frameworks: AutoGen, Google ADK, LlamaIndex, LangGraph, Pydantic, OpenAI, CrewAI, and sort of look at how they fare on each of these dimensions. Okay, so let's sort of walk through each of these libraries and sort of see the scores that I have assigned to each of these dimensions. So we can start with AutoGen. Multi-agent pattern support, really high marks here. The entire API is async first. It's sort of event-driven using the actor model. In terms of state management, you can sort of call save state and load state on agents and teams, team presets in AutoGen. In terms of observability, it does support open telemetry. And so essentially you can configure any open telemetry backend to sort of work with this. In terms of ecosystem and community, it's quite a vibrant community, very fast growing, about 40,000 stars, lots of examples. In terms of developer experience, there's both a high level API that lets you sort of build prototypes really, really fast, as well as a low level API that lets you sort of express very, very complex or business logic specific multi-agent workflows. In terms of debugging and evaluation tools, high marks here. And so AutoGen Studio sort of lets you, it's a no code or low code interface that lets you sort of drag in multi-agent presets, run them, test them, and then even reuse them back in Python. In terms of declarative specification, all of the components in the high level API can sort of be serialized to JSON, and then later runtime objects can be instantiated from those JSON or YAML specifications. And I think AutoGen gets the lowest marks on deployment capabilities, mostly because there's while you can integrate AutoGen agents, and there are a lot of examples that show you how to do that with things like Fast API and Chainlit and Streamlit. The library itself is not really involved in, does not sort of focus on exact deployment. We can compare the Google ADK. Let's switch to Google ADK. Similar marks on state management, multi-agent pattern support, developer experience, debugging and evaluation tools, asynchronous APIs. And in this comparison, I'll just focus on places where other frameworks sort of diverge from AutoGen. And so for Google ADK, we see in terms of event-driven communication, there are events, just not as explicit as what we have in terms of the runtime and message delivery mechanisms that we see in AutoGen. In terms of observability, it's there is a web UI, but it's not exactly clear how well you can sort of integrate like tools like open telemetry. Google ADK is still relatively new, so it gets lower marks on ecosystem and community. Very high marks on deployment capabilities. I think there's a clear, strong deployment story using things like Cloud Run, or I think the agent engine on GCP. And then for declarative specifications, it's not clear. There's just no support for serializing agents to JSON or YAML, so pretty low marks here. I think no other library sort of supports declarative specifications in the way that AutoGen does. We can also look at things like LangGraph, and so LangGraph, very, very similar in terms of scores. I think where it gets lower scores is the async API developer experience, and so I think it takes about 2 to 3 times more code to express the same concept in LangChain versus, let's say, the AutoGen low-level API or even other frameworks like CrewAI. I mean, there are pros and cons there. And then also in terms of declarative specification, it just doesn't support that. And then event-driven communication, it's not clear that LangGraph is, or it doesn't expose its event-driven messages or message exchanges as explicitly as how AutoGen might sort of explore the same thing. Okay, so next let's take a look at LLamaIndex. Again, good similar scores with AutoGen on ecosystem and community, similar scores on developer experience, high scores, async API. I think LLamaIndex does a really good job in terms of like having an async API. And for each of these dimensions, you can always click under evidence and questions and sort of review links to the documentation for each library that supports the score that's given on that dimension. LLamaIndex has good state management, a strong observability story. I think it also integrates well with OpenTelemetry, and you have the ability to use Arise, Phoenix, and other observability or OpenTelemetry sync tools. Some not as strong coverage in terms of multi-agent patterns baked into the library. It's also in some ways event-driven, and then also it does not have, like, I think I haven't seen like a high-quality no-code tool for debugging and evaluation. And I think it does have some evaluation capabilities. I think here it has the ability to visualize workflows, but not as comprehensive as something like AutoGen Studio. And then it also has a module for sort of measuring the quality of generated results. Also strong deployment story here, much very, very well defined. And then finally, it does not have declarative specifications. Okay, on to the next one. OpenAI Agents SDK. I think I've covered this in a previous video, but all very similar scores until you get down to multi-agent pattern support. Not too bad. Maybe it might be an 8 here. State management, there is some support there, not as strong as others. Let's see. Ecosystem and community, just not as big as AutoGen. Event-driven communication, not as clear as AutoGen. And then deployment capabilities, it's a bit of a lightweight API at the moment, so just different scores there. And then finally, PydanticAI, also really strong library. Let's see. Again, not really clear that there's event-driven communication, no support for declarative export of components. And then I think also Pydantic doesn't bother itself very much with deployment capabilities. Okay, so the goal in this video was to provide some pointers on where to start. And in my opinion, I think AutoGen and Google ADK and LLamaIndex and LangGraph are clear front runners. If you're new to building multi-agent systems, I'd recommend setting out with these 4 libraries. Of course, I should note that comparisons like these are subjective, and so every library is sort of evolving rapidly. Some features may be less important than others, giving you use cases. Some of the dimensions covered here might not be as important as other dimensions, and so maybe some type of weighted average or weighted scoring might be more useful for you. And then the definition of features across libraries might vary. So take all of these as just signal to sort of start your own exploration. In order to dig in a bit more, all of the data that's used in the tool that I have shown today is available on GitHub. And so if you went to vectordb/multi-agent systems with AutoGen, went to research and frameworks and data, and so you'll see that each of the libraries has a pretty extensive JSON file sort of containing all of the data that's used here. Overall, I hope you found this tool and the overall video helpful, and I'll catch you in the next one.